Hi everybody, hope you're doing well. So in this video, I'm going to go through some of the updates on the 757 and showcase some of the systems. But first, I'll start off with some commentary. I'll put up an image here of our frequently asked questions, and I'm just going to go through a couple here. But with regards to the release date, I'm not going to make any public predictions or projections of a release date or timeline. Internally, we have a timeline, and I'll say that in the next few months, we're hoping to enter an early beta of the plane. I actually just sent out the NDAs to our beta testers, including the BlueBird team. There's going to be over 60 people involved in beta testing of this plane. There's going to be 3 stages of beta testing that we're going to go through before we're comfortable releasing this publicly. So when we're probably, from anywhere from 2 to 6 weeks, even maybe 2 months out from being 100% sure on a release date, that's when we'll announce it. I don't want to make any sort of predictions or projections. What I will say is that it won't be the first quarter of this year, that's for sure. With regards to which versions of the 757 will be initially released, we're going to focus on the 200 with the Rolls-Royce and Pratt & Whitney engines, and then the 300 will come soon after release as a free update. For the 767, we'll show more previews of that at the Expo. We're excited about that, but the focus right now is mostly on the 757. And the 787, we're not going to have any news on that for quite some time. All right, guys, so here we are in the plane, in the flight deck, basically cold and dark. Now, you're going to notice, I'm going to point out a few things really quick here that you'll notice. Obviously, these lights, we have not hooked these up yet, these annunciators, so they're going to be constantly on right now. Some other anomalies here in the windshield. So I'm pointing these out because this is still a work in progress. I want everybody to know. This is probably going to be our last video that we make where like there's so many work in progress things. I think the next video, whenever that may be, we want the plane to be a little bit more complete. I totally understand it's always a risk showing the plane in this stage because people are going to notice stuff and think that, oh, we missed it or something. But this is right now in an early alpha stage right now. So there's going to be anomalies and bugs, and we're well aware of that. So I just want to make that clear, guys, while we go through this video. Now, I'll show you the EFB here. There's certain things I can't show. I've been sworn to secrecy, but we have, for example, I can't show the entire page here. This is the electrical page here. This is a debugging tool for us that we use to make sure that the systems are working properly. And for example, if I go here and I go and click on the fuel, this is the fuel page. Right now it's saying that this fuel pump is not actually running, it's just saying it's online because of the external power is connected. But if I go back, and again, I apologize for these menus right now. Let me disconnect the ground power. Okay, so now we go back into the fuel. Okay, so you see that there's no fuel system pumps that are online right now. So the first thing I'm going to demonstrate is the APU fuel logic. The APU will only drain from the left tank. And when there is no power connected to the plane at all, we're going to first go ahead and turn on the battery here, okay? And then when we go through the APU, and I'll kind of give a summary list of the features that have been programmed into the APU. What I want to remind everybody is that we're using schematic diagrams to program these systems, okay? This goes well beyond an FCOM or maintenance manual. This really gets into the deep functioning of the various systems. That's why it's taken us so long here, guys. But it's going to be worth it, I promise. But let's start out with this. Okay, so we have the battery connected. There's no external power right now. It's not available. And I'm going to go ahead, again, looking at the fuel pumps here. There's a dedicated DC fuel pump in this situation that's going to start when we start the APU. So the APU is going to go through its little byte test. I guess it stands for built-in tests. When you see the faults and the run, these are not just lights that show up. It's going through a test here. Okay. Once that test is successful, you're going to see that the DC pump here is kicking on. All right, and the APU is going to start. Well, it's already spooling up. So listen to the sounds. All right, so now what happened here, I should have switched over a little sooner, but now the DC pump kicks off, okay, once it gets AC power, and it's going to run through the forward left pump. And it's draining here from the left tank only. Another thing you'll notice here, we've mentioned the IRS system last year. Right now we have it set to instant on just for testing purposes. You will be able to set a realistic IRS time if you really want to sit there and wait potentially up to 20 minutes. Or you can do 1 or 5 minutes if you want, but right now we just have it instant for testing. So now the APU is running. See, the run light is on, it's generating, the APU gen light is on. It is on. Again, this is just another little bug I'm pointing out here. We're well aware of it. Like you can't see the on decal. It's minor stuff that we're going to go through. But the APU is running, and then there's also, let me move over here, there's duct pressure that the APU is providing, okay? So the isolation valve works. If we turn off the isolation valve, there we go, okay? So we want to provide bleed air to both the left and right side. We did go over the air conditioning system in a previous video. There's still some adjustments we're going to make to this, to the basically the pneumatic system, but we won't cover that in this video. But really, I'm going to go ahead and at this point, I'm going to kind of summarize all of the features that have been built into the APU. I'm not going to go through and talk about them all, the whole list, but I'll put up the list here so that you can see what we've been working, what's been programmed. This is not in works. This is what's been programmed into the APU system. It's a very complex system here, like a lot of stuff going on behind the scenes here. Okay, what I also want to go through really quick, in this case, in other scenarios, let's say you have the ground power hooked up, connection, and you want to start the APU. So it's available here. Let's go ahead and turn the battery on. We're going to hit the ground power. All right. You're going to hear the recirculation fans come on. The avionics will turn on. And then, if you remember last time, so these are the fuel pumps. Again, they're spinning to show that they're online. They're not actually trying to pump any fuel right now, but they're online. What we're going to do is start the APU, and then I'll show the load transfer logic. When you go from the ground power to the APU, you'll hear the relay click over. So let's start the APU. Goes through its little byte test. If we go into the APU screen, okay, you see it's starting to spool up, which is also what we're showing in our debug here, right? So one thing I wanted to mention is this is just not for eye candy here, guys. We're using this as a debug tool to make sure that these systems are working properly. All right, now you see the APU is available. The run light's on. The APU gen light is pushed in. Again, I know the decal. We'll fix that. So what will happen right now is if I switch off the external power, you see what happens there is the relay, the source changes, so you'll see just an instant flickering of all the avionics and the lights as it switches on to the APU generator. So I just wanted to demonstrate that's a function of the electrical system. The electrical system is really alive in the background. There's a lot of stuff going on. We really want to make this airplane feel alive. So it's really neat to see this kind of stuff. This is all again through schematics. Okay, so now in this segment, I'm just going to go through the hydraulic system. I'm going to put up a list of the features of the hydraulic system here. So just for a summary, I don't know if I'm going to go through all of this, but first thing you'll notice, we're cold and dark. You can move the rudder pedals, the control column, yoke, but it's not going to move the control surfaces. So if you're outside and you're trying to move the control surfaces, you're not going to be able to do that right now because there's no hydraulic power. Okay, and you guys notice here I'm using a base install flight sim. I had to reinstall my flight simulator, so I need to get my FS traffic and all that stuff installed. That'll be later. So apologies for the ugly standard AI in flight sim. Okay, so now what I'm going to do is I'm going to go ahead and start up the APU. We'll power up the hydraulic system. All right, now that the APU is running, avionics will come online. You can see the hydraulic pumps, the 3 hydraulic pumps are powered, and we're going to have some randomness to these numbers right now. I mean, we're still working on the hydraulic system. It's almost done, but these numbers are not always going to be the same here, so don't worry about that. What I'll do right now is, well, if we go outside the plane, now the control surfaces are working, of course. These are all attached to their correct hydraulic system. Now, for example, let's say if I depressurize the center electric, the system pressure light comes on. There's no pressure in there. So now you see only some of the spoilerons work. All right. And this is also hooked up to their respective circuit breakers. Now, we know pilots don't use circuit breakers, guys, but we've talked about this before as well, that we wanted to really have a deeply simulated electrical system, so that's why we integrated the circuit breaker mapping. It'll also be beneficial in the future for failures and things like that. Another part of the hydraulic system that I'm going to demonstrate in a video soon is the ram air turbine. The ram air turbine is simulated, and the ram air turbine only powers the center hydraulic system. It does not provide any electrical power. So in the event that you lose both engines and you're flying, the ram air turbine is automatically going to deploy and power the center hydraulic system so that you can control the aircraft, and then only these standby instruments are going to be functional. The fuel system, guys, and again, I'm not going to go into everything because I'm probably not going to explain it the best way, but all of the fuel system logic is there. If you don't have the correct buttons pressed, you're going to see a fuel config light, and let me see if I mess around with this right now. This is why I have the pilots to see, like, you know, the center. If I don't have the center pumps online, it's going to give me a fuel config message. This is all, again, based on the schematic diagrams of how the actual airplane works. And I'll go through and give a little summary. Of course, I'll post a little summary of the fuel system. So I hope this gives a little bit of an idea of the depth that we have so far in these systems. Okay, now let me briefly talk about the cabin pressurization system, since Dave is going to cover that in his video anyway. The cabin pressurization system is modeled to a very high degree. And it's in this page here. If I go to the home screen, you go into flight data, which we have a lot planned to do with the flight data screen. Right now, it'll show the cabin pressurization system, what altitude the pressurization system is at, versus what the altitude of the aircraft is at. You have the ability to go into 2 auto modes and 1 manual mode. You can select your landing altitude at the airport you're going to, and this goes to the complete range. The outflow valve, which is located at the rear of the aircraft. This outflow valve here is fully operational, along with the negative pressure relief valve, which are, if I move closer here, and I'm sorry I'm using these cameras, I hate these default cameras. These guys right here, these negative pressure relief flaps, they are functional, so depending on the status of the cabin altitude, it will open those flaps. And you can also get, there's a warning message on the cabin altitude. Again, Dave, I want to have a video by Dave, and he'll go through some of this stuff, but I'm going through it as well here just to give you guys an idea of what to expect. And I'll put up a summary of the cabin pressurization system as well, all of the things that have been programmed. So guys, we're putting a lot of work into this. For those that are new to us or might be just watching this video, we're programming the autopilot and flight management system completely from scratch. This is not using any of the default Microsoft Flight Simulator code. It's all coded by us. So right now, you know, the basic autopilot modes are all working, but really the bread and butter is the LNAV and VNAV. The LNAV, we've started on VNAV, and LNAV, you know, we're still tuning that, but we're kind of working on these together. So this alone is going to take a couple of months to get programmed. And you know, this also includes the auto land. This is going to be a full custom auto land. So these things have to be tuned. Once they are in a more complete stage, that's when I really want to make the next video. And again, all of these little minor bugs and stuff you see, and here, I want this to be complete. The virtual cockpit, I mean, the model and the textures is basically 95% done. Again, there's just these little bugs here and there that we have to fix to get it done. Okay, now I'm going to turn it over to Dave for his section of the video.
Hi everybody, welcome to this BlueBird Simulation 757 showcase for the flight management computer, and also a little bit of the pressurization system. So first of all, let's go down to the flight management computer to the route page. And what we're going to do is we're going to load up a route from KSTL, St. Louis in America, to Denver. We're going to use ACARS, which will actually integrate with SimBrief to go and load up your most recent flight plan. So what we'll do is we'll choose Request Send here. So this will go and retrieve your most recent flight plan, and it will offer to either load or purge the flight plan. And in this case, we'll load it. So from the flight plan, we'll load the origin and the destination, plus your flight number as well. The runway and any departure and arrival you will have to choose yourself using the flight management computer. And we'll go to the departure page, and we've got a full selection of all the runways, and then the departure. And once you've selected a departure, you'll then be given the option of choosing a transition. So that's the point at which you want to leave the departure. We'll just activate the route here. So if we go to the departure and arrival index page, we can choose Denver's arrival. And here we'll choose ILS 35 right. And then we'll choose a transition for the approach, which we'll choose Pearl here. And then we'll choose a star arrival along with a transition. So as we fly the route, we'll transition into the star, and then we'll transition into the approach. So now we'll just go through and have a little look at some of the waypoints that are on the way. We've got an altitude waypoint here of 1120 feet. And straight over to P Young on bearing 311. All the distances have been calculated. We progress through. Obviously we've got discontinuities and things like that now as well. I've already pre-planned a route with some points that we can go to. So I'm going to add in Croc here. And then to close the discontinuity, we can just go to the next page, select Oath, and then drag it onto the discontinuity. So that connects that waypoint to Oath. As you can see, we've got all of the speeds and all of the altitude restrictions as well at every waypoint. So this is a full route down to the runway with missed approach. So we'll climb to 5,800 feet, and then we have an intercept, and then we'll hold at Seduk. We'll execute that now. Okay, so here I've changed into plan mode in the EFS, and now we can step through all of the waypoints. So on the EFB we also have this app called the Flight Data app, which will allow us to view various altitudes for the aircraft, the terrain altitude and also the cabin altitude. So we can see what the pressurization system actually does. So if we go over to the pressurization system, we can set the landing altitude for Denver, which is 5,400 feet. It does normally move a little bit faster than this, but I think my video recording software is slowing the input down to Flight Simulator. So we also have the auto rate, we also have the various mode select switches, which actually each system, including the manual, is simulated. So in the future we'll be able to fail auto 1 and you will have to switch to auto 2 or manual. You can also use the manual controls to control this outflow valve at the back. And it will move also while you're flying around, including equalising the cabin pressure upon touchdown. It's fully simulated. I spent many hundreds of hours just on that part. So now with the flight management computer there's obviously two, and so we can actually independently control each one, including both routes, and manipulate them in whatever way we desire. We can switch to route 1 and switch to route 2, we can copy the routes, we can manipulate each route independently, and we can also look at other departures and arrivals. So here I'm going to type in Cayman, Memphis, and we'll look at the departures just from Memphis. Here you can't select anything on this particular page, it's just viewable information, that's all. So here I am travelling on the route. You can see LNAV is currently switched on. LNAV is something that is in active development at the moment. So as you can see, I've specified a new waypoint to switch to here, and LNAV is now turning us towards that. So all the bearings and distances are calculated correctly, and it will progress through the flight. So here we can see the aircraft's altitude as we've climbed, and the cabin is also climbing as well, with the terrain displayed below and 0 at sea level. So here I'm changing the rate of change of the pressurization system so that it can climb the cabin faster, which it will do in auto mode. It sticks to a schedule behind the scenes, specifically made for the 757. And it also has the cabin differential pressure, including the limiter at the top of the differential, plus the negative pressure relief valves. So at the moment we've got an landing altitude of 5,400 feet. Here we progressed on with the flight. We can see that we're nearing the upper limit of the differential. We haven't quite hit the differential, the limiter just yet. It's close to it, but I think given the altitude that we're flying at, cruising at, and the requested altitude of 5,400 feet, then we won't hit that limiter. Because if we did, then the cabin would be forced to climb with the aircraft, because the differential would be too much otherwise. It would exceed the limit. So to show the negative pressure release valves working, then I'm going to climb the cabin altitude to 10,000 feet. This is also going to trigger the cabin altitude warning light as well, because the cabin is not allowed to go too high, otherwise everybody would be suffering oxygen problems in the cabin. So I've increased the auto rate to maximum. It's now gone up to 1200 feet per minute, and it's climbing the cabin, which will cause the differential pressure to decrease in this case. And as we can see from the EFB, the flight data app, that the cabin is now climbing, the aircraft's altitude is stable. So we can change the rate and also decrease the altitude as well. So here I'm showing the progress page. You can see that we've burnt 13.4 tons. We've got 6.6 tons per side, slight headwind, and a very little crosswind. Currently minus 41 degrees Celsius. And here we can show that the speed and altitude limits per waypoint as well, ready for VNAV. And once the aircraft altitude comes down to meet the cabin altitude, then it will reach the limit of the negative pressure. And once it does that, then it will then cause the cabin to fall at the vertical speed of the aircraft, which in the next picture I'll show a slide of that. And in this slideshow you can see that as the aircraft's altitude descends, it eventually meets the cabin's altitude, and then in the center it goes into a certain amount of negative pressure differential, and then it starts to descend with the aircraft's vertical speed. And then in this slideshow you can see that upon touchdown we equalize the cabin's pressure with the ambient air pressure outside the aircraft. And then I'll pass it back to Shervin. Thanks for joining me.
Thanks, Dave. That was great. So I hope this video was informative. It's longer than I expected, and also took several days to make and several takes. So you notice in certain areas it was fragmented, but I really just wanted to get as much information as we could. But again, it was longer than I thought. What makes this video really different than from our previous videos is that certain areas are finally ready for beta and other systems are coming together. So it's really nice to finally see that. We're working hard to make sure that the code is optimized through our various debugging tools, and the team didn't want me to show all the debugging tools. I just showed you the fuel system and part of the electrical system as well, debugging tools. But we have other tools to help with the performance to make sure that no system is taking up too many frames. It's really important to us is to make sure that this is optimized. Now, if you've stuck around this long, what I want to do is just go through some extra updates. I'll start off with the virtual cabin. It's finally in the texture shop. In the next 4 to 6 weeks, it'll be ready to merge onto the model. We're going to have 2 versions of the cabin based on the exit door configurations of the 757. We're not going to do any extra cabin work for different airlines and things like that, maybe after release, but at this point, we're just going to stick with the 2 versions. The landing gear is finally getting textured, and that should be done in the next couple of weeks. It's looking great. This is in Substance Painter. The ram air turbine, this is the model here. Obviously, what you saw in the video was just a mock-up for testing. So this is what the model of the ram air turbine is going to look like. Very detailed. A little too detailed, I would say, but hey, we love detail. And finally, with regards to the 757, we showcased some previews of the cargo expansion or cargo version earlier this month. So the cargo version is going to have several enhancements that will be included for free on the passenger version. The cargo version will be a paid expansion pack, but you don't need to buy it to get those improvements. But we certainly hope that you do buy it and support us. But here's some extra screenshots of the cargo version. It's looking great. And then, regarding the 767, We announced this 2 years ago, but at any given time, there's no more than 2 people working on it. Once we get the whole team on the 767, it's going to progress much faster. So, right now with what we're working on, the code base, and we're making great progress on that, it's going to really help future projects progress much faster. We're going through the hard part right now of developing, of getting the code base done. That's really the most tedious part, but we're getting there. We're making great progress, as I mentioned. So I hope you enjoyed this video. For the next video, it's going to be, when the plane is more complete. So I'm not going to give any sort of timelines on that, but I want the plane to be in a more complete stage before we make another video on YouTube. But on other social media, I'll post snippets here and there just to keep everybody up to date. Facebook and Instagram. I even got roasted for posting on LinkedIn. I do that from time to time on LinkedIn. But I will keep you guys updated. As always, I appreciate the patience and support, and I'll see you all next time.